In this question, we're going to put, we've already a sphere drawn in elevation, we have a sphere drawn in plan. Now, this sphere is radius 40, so if I write it on, radius 40, we can imagine this as, for example, a tennis ball. Now, in this question, we want to put another sphere, so we'll call the other sphere maybe a golf ball. And we'll say a golf ball has a radius of 20. Now, we want to put the two solid objects touching one another. So, all we know about the golf ball is it touches the ground, touches this. So, from the ground, how far up is the center point? Up 20. Okay, so it's up 20. So, the first thing we'll do in this question is measure up 20. And what I'm going to do is draw a light line across. So from the 20 mark here, draw a light line across. Now, so we have a light line drawn across there. Now I might make it a bit heavier so that you can see it. Now, so that's up 20. Now, to do this question, we know they're touching off one another. They're touching off one another on 1 point. Now, we could always guess the 1 point. Now, we're not going to be accurate at guessing it, because a couple of people in the class will say they touch here. More people in the class will say it touches here. A few more will say it touches here. And a few more people will say it's up here. Okay? Now, in tech graphics, we can't be guessing because it's technical. Okay? Now, so what we have to do is, we have to figure out this bit of information. From the center point of this circle over to the center point of the other circle, how far away is it? 60. Where are we getting 60 from? Yeah, so what we're doing in this question is we're taking this 40 mil here and we're taking the 20 mil here and adding them together. So what we do in this question is we add our two radiuses together, so setting our compass to 60, and go from where then? So the center of the large sphere, and scribe an arc. Now, this means that from here to here is 20 away, and then from here down to ground it's 20. So that's the correct position. So if we finish it off then by setting our compass to 20, place our compass here and draw our circle now. What we'll see here then is it's touching here and it's also touching the ground here. Now, the last bit of information is we need to find a point of contact between the two of them. Now, can anyone tell me where the point of contact is? It's not 90 from the center. Join the two center points together. So we go from the center here to the center here, and they have to touch here. It's the only place that they can touch. Now, to draw it in plan then, all we're going to do is bring our point of our circle straight down. And where are we going to find it on that line? Now look at where it's drawn in elevation. In plan, where is it going to be? So a line from the center point straight out here. And what we're going to get is, this is our center point for our circle. And what we're going to do in this question then is draw the plan of this circle. And the one thing about the plan of this that we should know, it overlaps, and then determine which one is covered. You look at the elevation and you'll notice that the small one is going to be covered by the large sphere. So this is what we're looking at It could be a tennis ball and a golf ball put side by side. Now, the final thing to be done in this is to find the point of contact. To find the point of contact in plan, you bring it down from elevation, straight down, and it's in this position here. And then in elevation, write POC for point of contact, and in plan, write POC, point of contact.